All right, last reaction in this series or for this day of lectures, I promise. But let me just set this up by doing a quick review from the last lecture. Previously, we took an alkene and made it an epoxide with MCPBA, and then added water with the presence of an acid catalyst, and that did an anti-dihydroxylation. Now, one of the things, hopefully, going through your mind is, well, if I can get the OH groups anti to each other, is there a way to get them to be syn? And there is a way. I know you're kind of probably disappointed, like, no, I don't want to do this. It just looks a little bit different. One method is to use osmium tetroxide and then sodium bisulfite in water. Now I'm just going to look at the first step in terms of a mechanism. Like how do we get OHs on adjacent carbons and have it be syn? So here's osmium tetroxide. And this is a concerted mechanism. So I'm going to use the pi electrons to make a bond to one oxygen. These pi electrons will move to the osmium. These pi electrons will make a bond to the other carbon. And we get this weird looking intermediate. But I want you to look very closely to this. Notice how those two oxygens are syn to each other. And then all that needs to happen, you do not need to know the mechanism for this, but in the second step, that's where we add the sodium bisulfite and water. And that gets to the syn addition of those two alcohol groups. Now, let's talk about stereochemistry real quick because I made a chiral center. What do you notice about this? Well, there's symmetry there. This is a meso compound. Now, that doesn't always mean when you do a reaction with osmium tetraoxide, it's always going to be meso. So I'm just going to change this 5-membered ring up slightly. And here are 2 steps. And that osmium tetraoxide, and I'll draw it out here, can add to the top and it can add to the bottom face. Now, why didn't I do that with this one up here? Because it was symmetrical. Adding it to the top or the bottom is the exact same thing. But in this case, is it still the same thing? No, these intermediates are enantiomers of each other. So when I add the sodium bisulfite, OHs are up here and the OHs are down here. Is this a meso compound? Neither of those are meso compounds, and so this is a racemic mixture. So don't get always in the mindset, oh, anytime I see osmium tetroxide, like it's automatically gonna be meso. No, you have to consider it because I'm adding the same group across the double bond, but that doesn't mean it's a certainty. Now, I want to kind of talk about some alternative reaction conditions that do the exact same thing. Because one of the downsides to this reaction is it requires, if we use these conditions, a 1-to-1 mole ratio of osmium tetraoxide to the alkene. The downside of that is osmium's a heavy metal, kind of toxic, not good to get into water supplies or anything like that. So the less we can use of it, the better. And one option is instead of using a 1-to-1 mole ratio, is we'll use a catalytic amount of osmium tetraoxide. And then another compound called NMO, which is an oxidant. This is the structure of NMO. You don't have to memorize it, just know the acronym. But if you're kind of interested, oh, what is it? What does it look like? This is the structure. The name is N-methyl morpholine N oxide. And it does the same thing. It does a syn addition of two OH groups. You just don't need as much osmium tetroxide. And one other alternative, if you don't want to use osmium tetroxide at all, is to do the reaction in cold temperatures with potassium permanganate. And then the second step of aqueous sodium hydroxide. And that helps us to avoid using osmium tetroxide. One of the downsides, if you're not very careful with this reaction, you're not paying attention, is the permanganate ion is a very powerful oxidant and may oxidize the OH groups further. So you have to pay really close attention. Sometimes it happens, regardless. So it's not always the best alternative. Most scientists kind of settle on, well, let's just use a little bit of osmium tetroxide and that's kind of like the happy medium. So that's where this will end this days of lecture. And we'll have one more set of lecture videos, but I highly recommend start practicing these reactions. I'll have practice problems up. I'll have the problem set up on Canvas because this is going to be a huge part of your exam, reactions and mechanisms.